Next curve.
Rounding out our morning's general session is a dynamic conversation at the intersection of two game-changing technologies, AI and sensors. And in this leaders roundtable, we'll explore how sensors power AI and how AI is now shaping the next generation of sensor innovation. So get ready for insights into real-world applications, industry breakthroughs, and what's ahead for this powerful tech symbiosis. Our moderator is Leonard Lee. He's executive analyst and founder of Next Curve. He has over 25 years of experience advising global 500 companies on technology and business strategy. Leonard is a recognized thought leader, former Gartner partner, and contributor to Forbes, Bloomberg, and more. And Leonard, I'll let you take it from here and introduce your panel.
Hey, thank you. How's everyone doing? Good morning, everyone. And before we get started here, I really wanted to congratulate the team at Questex as well as Sensors Converge for 40 years. I think that's quite incredible. So if you don't mind, why don't we give the team a hand? And now I'm really excited to be moderating this panel. I think everybody in this room has been on the exhibit floor and has undoubtedly seen a lot of sensors and probably heard a lot about AI. And over the past few years at Sensor Converge, we've seen AI sort of make its way into the sensor discussion, especially as it pertains to smart sensors. And, as many of you who have been in the industry know, this isn't anything particularly new, but it has become very exciting in the past 2 years, especially with the advent of, ChatGPT, generative AI, and the widespread recognition of transformer-based models. And so I have a distinguished panel here. And if everyone will take a moment, a very brief moment, because we have a number of panelists here that I'm sure will want to spend their time talking about how the convergence of AI and sensors are going to create new possibilities. If you don't mind introducing yourselves really quickly, and then we'll get started with the conversation.
Absolutely. Manuel Cantone, Product Marketing Manager with ST Microelectronics. We do provide to the market components, sensors, so MEMS for motion, for altitude with pressures, and temperature and the like.
All right. Yuhao Long, I'm the co-founder and CTO of InforMove. We build robots that deliver grocery and packages to your door. Besides the one that you may already see on the road, we also equip a robot arm on top of it, so it can interact with the environment a lot.
My name is Rob Watts. I'm the lead architect of a software framework called Intel Seamscape. I'm with Intel Corporation. We're still around. And that Intel Seamscape is a platform for bringing AI and sensors together to create 4D digital twins of spaces.
I'm Azita Arvani. I'm former CEO of Rakuten Symphony Americas, and also I've been working a lot on AI and networking, and I think AI, networking, and sensors provide a very fertile ground for the future of this area, and I'm really excited about the panel discussion.
Hi there, Simon Ford from Beacon. We do a Bluetooth-based network, so for very low power things like sensors. And before that, spent 17 years at ARM doing things like introducing the Cortex-M microcontroller range. So very interested in microcontrollers, computing, software, services.
So I told you, amazing panel. So thank you all, and why don't we get started here? And I'd like to kick things off with a question of what's really gotten you excited coming into Sensors Converge as it pertains to or relates to AI and sensors. Every year we come to the conference, there's always something new, and it seems like the velocity of innovation is just quite overwhelming. But what are the things that have you excited that you think are going to influence where this convergence of AI and sensors will take us? So Simon, why don't you start?
Yeah, okay. So obviously I've spent a lot of time seeing processing technology, radio technology, sensor technology improve. It's just like a constant chipping away at that sort of roadmap. But I think for me, the thing that's changed is actually the perception of what's possible. So a lot of this technology has been getting better and better, but sometimes you don't notice how much it's improved. So actually, the hype, the advancements in things like the AI services that people have become more familiar with, I think that's actually unlocked imagination in a way that I haven't seen for a while. So it's surprisingly not directly related to the technology, more how people are approaching problems.
So for me, if you look at sensor, the four main parts of sensor, the sensing element, the processing unit, the networking, and the packaging, and the convergence of all that can make it possible for things that we haven't seen before. So for me, since I work a lot on the networking side and the processing side, you could see that this continuum of intelligence, right? You could put the processing on the sensor, you could put it on the network, you could put it in the cloud, depending on your requirements. And you could even then later change it dynamically. Like, let's say you decide that for whatever reason you want to do the AI in the cloud. So your sensor collects the information, does some processing, and then sends it to the cloud. But then there is a security breach, and then you don't want to send everything to the cloud. So you want to do it on the edge. But being able to change things dynamically, that almost like an intelligence supply chain, that to me is super exciting.
Yeah, I think a little bit about how we're all born. We're all born with a lot of sensors, right? We have our ears and eyes and touch and, 5 senses apparently, but actually there are more than that. We have an IMU built in. But when we're born, we don't really understand how to use those senses, right? And so our brains make sense of that. That's the intelligence. It's the thing that takes that those sensor inputs and actually grows based on those sensor inputs. And I really think that's how AI and sensors come together, is the ability for the AI to learn from the sensing, to become embodied, to understand the world, to understand our bodies, and to be able to act within that world. And I really think sensors have been very difficult to use and very specialized. Like every single modality has a great deal of specialization around it. And it makes it difficult to start bringing those sensors together. And I think that's where AI really comes in, to be able to embody the collection of all those sensors together into something more than just the sum of the parts. It's like much more than that. It's really giving our applications and software the ability to interact with the world in new ways based on the plethora and the collection of that sensor data.
Yeah, I just want to follow up what Rob just said. It's like in today's technology, we can really fuse a lot of sensor together with the transformer architecture and basically build a very holistic view of the world. Besides that, another trend that I see is we actually having this actuating sensors now. Because when we're talking about sensor before, we're thinking about cameras putting on a building, which always pointing in the same direction, like a CCTV camera. But when you're thinking about a sensor on a robot, it actually has the way to kind of moving around and pointing to the direction it's interested in. So the capability of extracting data from the world has been increased a lot by the capability of AI.
I'll connect to what Yuan said and what Zita said. So you talk about the robot, so we're talking about battery-operated things that are independent. So power consumption is key. And to Zita's point, edge networking, so distributing the computing across the cloud, let's call it gateway or whatever the mid object is, and then a sensor node. I come from a semiconductor company, so for us, the sensor node is built with multiple ingredients. So there is a sensor itself, that's my product, and then there might be a microcontroller or a mean of connectivity. And you can distribute the computing even further down to the sensor itself, where the data is acquired. That's really our goal here, is to make the sensor aware of the context. Contextual awareness is a leitmotif of our booth. You will see it in all our demos, so that we can basically stream only significant data or decide when to stream significant data to avoid the constant stream of raw data and that in the end consume power and back to the independent robot consume battery and reduce the time of these devices. So really moving the intelligence all the way down to in sensors. So we said in edge, and then in edge capabilities is the common term accepted by the industry. In sensors is what we said in our company, and we can do classification of movement. We can do things like FFT directly on the sensor, so that we can not stream raw data, but already pre-processed ones.
Okay, great. So, Manuel, since you talked about, or at least have set us up to talk about AI's influence on sensors or sensor solutions, what are some of these new developments in AI technologies, AI capabilities? How have they shifted your thinking about how sensor solutions come together, whether it's from a device perspective, overall sensor or perception system architecture perspective? What are those things that you could share with the audience?
So our mind shift when we talk about AI is really providing our developers the tools to take advantage of all the computing that you have in all the various pieces of the architecture. So tools to take advantage of the intelligence in the sensor, tool that might be a different tool than taking advantage of the processing capability of the microcontrollers. Even the most common microcontrollers can run some AI with the right tools, synthesizing the light library. So it's really a mindset going more of a software and programmability oriented mind shift rather than providing a sensor that just is registerable. It's configurable to registers and then just send data away.
Yeah, so for this question, I was thinking about when I was doing self-driving in around 2020s. At that time, we first built a 8-megapixel camera for automotive usage. But one feature that we make sure that we have in that sensor is we have to have a capability to bringing 4 pixels together so that the camera is not using in 8 megapixel but 2 megapixel. Because at that time, that is the maximum capability that we can extract information from our AI model. But today, that becomes different. Like the model capability, the semiconductors capability is being increased a lot. So we can actually extract useful information from every single pixel in that camera. And secondly, I want to really go back to the actuating sensor part. That back in around 2020s, we are talking to several LiDAR companies who has the capability of directing a laser beam to a specific area to form a denser point cloud for a specific object. For example, if you see a car driving towards you, the sensor can actually kind of be focusing on that area to see much more detail on that car. But unfortunately, none of the LiDAR company's customer can take advantage of this feature, because at that time what we have is only probably a rule-based, at best a simple model for changing this configuration of a LiDAR. But now it's different. Like now with the capability of AI, especially I would say like reinforcement learning with verifiable result, this kind of algorithm, you can actually pointing your sensor at a specific location that gives you the best result if you formulate your goal very specifically. For example, if you're thinking about like if you ask a robot to pick up a water bottle on the table, you don't need to build a rule-based system like say the robot head has to point him to the table for manipulation. You can train all these joints all together, including the neck, including the head position all together to make sure the end result of the task has a maximum successful rate. I think this is how AI changes the usage of sensor.
Well, I think also about calibration, right? I got a new pair of glasses the other day, and when I put them on, I started getting a headache because they were a little different than my previous pair, right? So it took a little while for my brain to recalibrate when I got those new glasses. And I thought about that because when we calibrate cameras for doing multi-camera tracking or whatever, it can often be a pretty onerous process for a person to go in there and get the pose and intrinsics and extrinsics of that camera. And we try to make that as easy as possible in our systems, right? But ultimately, the AI needs to learn how to integrate those sensors with the sensor input itself, and bringing, like you said, AI down into the sensor itself in order to better understand how that works, to reduce the friction of integrating new sensors into these platforms. And I think that being able to process that data and use the data with AI for getting a better understanding of where the sensor is, what the sensor parameters are, without having have an entire test bench for doing that. I think that's a really critical direction, to be able to bring the sensors together in a more seamless way using AI.
So a little bit following on what Rob said here, I think adaptive sensing also can be very useful, not just being able to look at the data afterwards and calibrate to things, but even the way we sense. For example, if the temperature goes high, you might want to get the readings more frequently. And so just the sensing itself could change. I'm on the board of a company called Tennant Company, and we do industrial and commercial cleaning machines, so the big sweepers and things that you see at airports and so forth. And we have a line of robotic machines now. So the first generation was when it saw some barriers or some kids coming in front of it or something, it had to kind of wait for an operator to come in and clear things. But now it's much easier for them to, when the camera sees it, it takes more pictures when there's a barrier, and it can go around it, and it becomes much more autonomous and adaptive to taking care of error situations. So I think that's very exciting. But I also want to talk about AI in design of the sensors, which I'm sure Manuel knows a lot about, because that's when generative design comes in, right? So when a designer just does design on its own, it might take much longer to come up with all kinds of permutations and configurations of past design, and being able to take advantage of that to meet the requirements that they have. So this is almost like creating new molecules and stuff that for a person it'd be much harder. But if you have like a super creative AI assistant, they can do that for you much faster and easier, and being able to look at many prior designs, not just from your company, but other companies, then that makes that much easier to design better sensors.
Yeah, so you were saying about changes in thinking. So I think there's some things that are quite counterintuitive if you don't stop and think about it. So processing on a microcontroller that might be in a sensor has be getting pretty powerful, but it's quite counterintuitive that you can apply that to reduce cost or reduce power. So most people would think, oh, if it's a more powerful processor, well, that's more expense, and that's more power. But actually, in physics, things like radio scales a lot worse than processing. So if you're on a latest generation processor, actually you can do a huge amount of processing for the cost of sending a bit of information. So when you start looking like that, actually applying advanced processing and AI in a sensor actually has the opportunity to reduce the cost of sensors, reduce the power consumption, which has a knock-on effect on cost, how long they can run on batteries and things like that. So, it's pretty obvious, but I don't think people perhaps, track how advanced the processing is available in what you would consider a low-cost microcontroller now, and how that can change your design decisions about if you can turn information from a high bandwidth sensor into a low bandwidth, higher order information, that can really impact the cost structure of your product and your solution. Yeah.
Yeah, it's interesting that you bring that up, but then also what I'm hearing on Exhibit 4 quite a bit is the topic of memory. being important, especially for these AI applications. So thanks for sharing, everyone. Now, one of the things that we are starting to hear a lot about is how data has become gold again. I don't know when it has become ungolden, but apparently it is gold again, and it is a very important input. Let's call it fuel for this new variety or this new generation of AI that we're looking forward to, right? And so, and this is interesting because we're talking about a recognition about the importance of sensors from, folks that are doing all the AI supercomputing, right? I mean, it comes into those conversations even, whether it's for the data center or even for the application. So I was wondering if the panelists can share their thoughts on how sensors and the way that they're evolving and advancing are enabling and impacting what's possible with AI, and what are some maybe, alternatively, what are some of those things that new sensor capabilities are going to enable for the future of AI as you see it in the next year, considering how fast everything is moving. So, you want to start off?
Yeah, sure. So I think, well, certainly from our perspective, if you can bring the cost of sensing down, it can go much further. Anything, if you reduce the cost, the amount of places it could be applied explodes, right? So for us, seeing that curve, allowing people to get insight into physical environments, physical products, often where it's not a first order objective of a product. So most people are thinking about sensors as a first, it's the first order thing. It's the thing that defines the product. Actually, what's quite exciting is when data sources aren't the thing that define the product. They're what give you insight into how, let's say, a product is being used, and therefore you can improve the product. So in the web world, it's been standard for many years to have analytics coming from, your SaaS product. You know exactly how your customers are using it. You know exactly when things are going wrong. And there's no reason why that doesn't apply in companies working in the physical, in physical environments. And I think that these curves allow that kind of technology to be applied in physical products, physical environments, where if you have insights, well, now you have the data sources to be able to chuck the big AI at it, and that's quite an exciting combination, I think.
Big AI.
Big AI, I like that.
Yeah, so to build on that, the sort of human-machine interface and the information that you get from your sensors to see if you're on the right track or not, that has a lot, that could help shape the future of our products, and AI can help it analyzing that. So in the digital world, we have all these sentiments, right? Like we look at social media and somebody saying, I like it, I don't like it, whatever the reviews and so forth. So this could be like another way for us to get information. So it goes from being sensor design for the requirements to the interface to the system, right? So I think that's super important. But also I would like to go to this notion of the connectivity and sensors, because you said data is gold. It was oil, now it's gold. That maybe it'll be Bitcoin in the future, but crypto. But if oil is obvious, data is obviously a big pillar of AI, and then there is the compute, and then there is, to me, the networking is the third pillar, right? So you want the data from the sensors to meet the compute at wherever is the best place to meet, right? So that best place could be on device. Some people call that edge AI, but for me, there are multiple edges. Or it could be at the edge of the network, and network has many edges. Or it could be in the central cloud. But that decision of where the data and compute meet, and how the networking shapes that is hugely important, and that could sort of impact how we get information and use it for our future use of AI.
Yeah, I think about what sensors are for, right? Sensors measure something in the world. They help us digitize the world. right? And if in the context of AI, it gives grounds the AI in reality, right? If you think about an AI as being entirely synthetic, you have hallucinations that start coming up because it's just operating on its own without any grounding in reality. And I tend to think about like dreaming, right? We go to sleep and our brains are just going crazy, right? They're just like coming up with all sorts of weird stuff, and it's not grounded in reality. You can fly, you can do whatever it is, right? And that's what the AI does without sensors, right? It just hallucinates like mad. And so the idea here is that we use our sensors to inform reality, and sometimes that's not comfortable, right? It's not what we want, but it's reality, right? So that's what sensors do. And the second thing is, as we use these sensing to create this world, this mirror world, this digital world that lives in the compute and in the AI, the sensing inform, like how well you can sense and how well you can compute informs the fidelity of that digital world, right? And I work at Intel, so I think a little bit about Moore's Law, right? So I think about how the sensing informs the fidelity of that digital world, and as we go over time, that fidelity is going to improve more and more. Like robotics, like you're going to be able to track, map the world and track where things are. Maybe you can do it within a few centimeters today, but if you want to take this into like industrial and manufacturing, it needs to be down at the millimeter and even more, right? So with better sensing, better compute, and better AI, we form this virtuous cycle of value that can help improve over time, and it's all informed by the data that comes off of those sensors, right? And so that virtuous cycle is really where we're going, and I don't think it's going to end. It expands both to smaller and to grander scales, all the way to the universe, if you think about it. So when they say, well, where I saw this morning, there's this tapering off of the amount of data. No, this data is just going to keep growing and keep informing that fidelity. Sure, it may be true based on the things that are created by humans, but the universe is vast, and sensing is what gives us the access to that.
Yeah, absolutely agree with what Rob said. Like for a robot builder, I do need a lot of data. I do need a lot of high fidelity data for sure. And also back to what Rob talked about on his first point, like sensor is the grounding of physical AI. Like for better grounding, we need multiple modality of sensor data coming all together to the robot. And today that is actually possible. I think everybody in the seats has already used a VLM, a visual language model, which is a kind of sensor fusion on its own, right? It fuse the visual data and the text data all together. With the same architecture, we can fuse visual, audio, even touch sensor together. And this is already being researched and being verified by a lot of research today. By fusing all these sensor modality together, we have the capability of increasing all the successful rate for specific task. And I would say like not only the high fidelity data, but also more modality of data coming from more modality of sensor that is going to be used for building better AI.
Following up on what Yuan said and also Rob, the fusion really resonates with me, because sometimes you need to confirm what the sensor is actually sensing with other type of sensors, and that's what the technology is advancing. So, take for example, a motor control. So you can sense the motion, but you also can sense the currents of the motor. And if something happens, you have these two things that need to agree, otherwise it's an hallucination, to your point. So, and the data multiplying and increasing and having multiple sourcing data that can be fused together, I really see it as a market trend. That's where we're going, and multiple modalities. The motion, the current, but the vision, and the vision that not only is vision cameras, but also vision distance or vision like temperature in a space and things like that. These are all things that our sensors do enable, and I think that it will definitely increase the awareness of these objects that move in the real world there.
Okay, wonderful. So, Rob, you said something really interesting, this whole notion of the virtuous cycle here, and I assume that you're talking about the virtuous cycle that is formed by AI for sensors and sensors for AI, right? Yeah. And so this final question that I'd like to ask the panel is this: is, you know, for the audience who probably are wondering, okay, so this is great, you know, visionary stuff, but what are some of the takeaways that they can go back to their teams with in terms of, you know, opportunities, near-term takes that you would recommend based on this idea of the virtuous cycle that you outlined? Because I think it's really important, because someone mentioned smush. This is like those two themes smushing together, right? So what are some of those salient points that you would like to share with the audience or recommend to the audience? So maybe Simon, do you want to talk about smushing?
Yeah, so I think from what I see when we're talking to customers, it's the underestimation of the amount of intelligence that can be put really into what would be considered a sensor, like Manuel talks about. I think when you start like that and you're thinking about how much intelligence can be put in what would be considered often a dumb peripheral or something like that, and that might recalibrate how you're thinking about a problem. So you know, and this will extend down to the way sensors are manufactured. You know, so not don't think of them as discrete things. Think of them as embedded things. Think of them as printed things. You know, printed batteries and all that sort of stuff. So I think resetting how sensors are considered as rather than being peripherals but being autonomous devices, even when they're considered very, very low cost, very, very tiny things. As autonomous systems, I think that recalibration is often very useful for a team.
Yeah, so for me, the mindset of going from traditional sensors that were kind of dumb and just sensed, and then going into smart sensors that are connected sensors, you know, the IoT sort of world. And now we're on the cusp of AI sensors, right? So then the sensing and the analysis, maybe some of the decision making can be done on the sensors. And that's something that definitely in the next 12 months. The other thing I want to talk about is synthetic data. That's something that that's also here and people can use. So instead of taking all of the data that's being sensed and sending it to the cloud or processing it, you could sort of freeze dry it and then decide what you want to do with it. And then later you add water and voila, you have data. So, but that's, again, I'm talking to some companies that are doing this in various areas, and that's something that could be useful for folks, and that's in short term.
Yeah, smush, right? When you say smush, I think fuse, right? Fuse.
Yeah, that's probably a better word. Yeah.
Sensor fusion. You know, what do you need to do, like in robotics, like Johan was talking about, what do you need in order for those sensors to be able to work together? Of course, to see this point, you need to be able to connect to them. And you need to be able to take multiple sources of data and maybe feed it into a multimodal foundational model or something like that. But to me, I have a background in physics, right? So I really want to bring everything into the same context. And I talked about this yesterday in my talk, but it's about every sensor being able to be localized in both space and time, right? So don't think about your sensors as being living in their own domain, right? Everything lives in space and time. And so how you can bring all of that together, precision timestamping, things like PTP, you know, precision time protocol, being able to integrate that with the network and be able to understand exactly when the photon hit that sensor or when that sound wave hit the MEMS microphone, right? Those, and being able to precisely timestamp that as well as to localize where that camera, that sensor, that microphone is in a common way. Now, if we can bring the space and time elements together onto the data, now the AI has full context for what to do with that. And now we can reconstruct the world in a higher fidelity way based on the synthesis of all of the different modalities. Whereas if you don't have that synchronization in space and time, then it's noise, right? You don't know what to do with that data. So those fundamentals of space and time, I think, are really near and dear to me. And I think that if we can do a better job of our sensors all working together like that, then we can enable that virtuous cycle.
That's absolutely very important as like not only in self-driving smart cars or like robotics where like have all the sensors into a single timestamp is very important to have a better understanding of what is happening. And besides that, I want to add, like, if you are a sensor builder today, if your company is building a sensor today, I think it's time to open up more controls to your customer about like how to do this sensor. Like, for example, if you're a camera builder, you can leave the interfaces of ISP tuning to your customer right now, because now the AI capability is strong enough to do that on the fly for better sensing. I think that is going to be one thing change a lot in the coming few years.
Back to the original question of pushing things together, right? And it seems like a forced marriage between the AI and sensor. I think really to make our customers understand that the potentiality is really the importance of tools and open examples, so open source examples that are available, and that all our company needs to do their own work of development with our own sensor, and then publicize it and socialize it so that people can have starting points and really grasp the real potentiality. It's not a new technology for us, but we really see now the adoption that more things are available, that tools are easier to use and really easy to access. So I think that the open source in the community is really important in accepting the marriage that seems forced to begin with.
Okay, wonderful. Well, thanks for that. And you know what? I think we invented a new term. It's called sensor smooshing. So it's incredible. But panelists, thank you so much. It's been a wonderful discussion, and appreciate the sharing. And everyone, please reach out to them. They're very knowledgeable, experienced, and have some great thought leadership that they can, lend to you. And if you don't mind, round of applause for the panelists. And thank you so much for attending, and enjoy the rest of the conference. And congratulations to the folks at Sensors Converge as well as Questex for a wonderful 40th year episode of the event. Thank you.